Good morning, everybody, and welcome to today's webinar. It's a SEND webinar today about hearing for life and how can hearing protection support. My name is Els, and I will be moderating the webinar in the background, meaning that, as usual, you will all be muted during the presentation. So you are not able to speak out loud, but we do invite you to enter your questions in the Q&A panel of this webinar. The chat is disabled for all the attendees, so please use the Q&A that you should find at the bottom of this Zoom panel somewhere on your screen. The speakers will go through their presentations, of course, but as much as possible, they will provide you with answers to your question. Should your question remain unreplied, please don't worry, because we intend to make a Q&A report available. You will, of course, be informed when that is available for you. We are also recording this webinar, so we will make available the recording and you will be informed as well when that is online. Should you be on Twitter, please feel free to talk about this webinar. We have a dedicated hashtag training for standards, and you can find SEN and SENELEC via the handle @standards4EU. So without further ado, let me present the speakers of today. First of all, there will be an introduction done by my colleague Jennifer. She's project manager, energy and living, taking care of healthcare standards at SEN and SENELEC. Jovan Alongo, she's the chair of SEN TC 159. Working on hearing protection, will introduce the work of the TC. Next is Magnus Johansson. He's the convener of Working Group 2 of that TC, working on electronic and amplitude sensitive hearing protectors. Peter Sickert is convener of Working Group 5 of TC 159, working on the selection and use of hearing protectors. And then last but not least, Sandra Dancher is the convener of the Working Group 6 of that same TC. Will guide you through the general requirements and test methods of hearing protectors. So welcome everybody, and I would like to invite Jennifer to introduce SEN and SENELEC now.
Thank you, Els, for that introduction. Do I have the control?
Yes, I think it should be working now. I lost it, so it's your turn. Yes.
Thank you. I suggest that we jump right into it. Today, I'm going to give you a quick introduction to SEN and SENELEC and how you can be involved in standardization activities. So who are SEN and SENELEC? SEN and SENELEC are two public standardization organizations with a common secretariat and a common system of rules to serve the interest of their members. Our members are the National Standardization Organization of the 27 member states of the European Union, together with the United Kingdom, North Macedonia, Serbia, Turkey, and we'll also have the 3 countries from EFTA, which is Iceland, Switzerland, and Norway. So these are our members. So here's to give you an overview of our members. So the member state France, our members there is AFNO, and for Germany, our member there would be DIN and DKE, and for the Netherlands, our member there would be NEN and NEC, and so on and so forth. Standardization happens at different levels, at national level. So within these members that I've just mentioned, and they can have their own national standards. And at European level, SEN and SENELEC have been recognized by the Regulation 1025 of the European Commission to develop standards at European level. And of course, at international level, ISO, IEC, and ITU are developing standards at international level. And it's important to mention that we cooperate with these organizations at international level to have a common European and international standards. I'm unable to move to the next slide. Yes. So standard is a tool for competitiveness of European businesses, meaning that when you have one European standard, it means that you have 34 identical national standards, and also meaning that all conflicting national standards are removed from the market, giving you access to millions of consumers. So with this being said, standards facilitate European trade because they reduce technical barriers, and they boost and enhance the confidence of consumers in the European market, because then you are sure that the products and the services that we come in contact every day are made of a base of quality and safe standards. We also have a concept of corporations with European organizations. So if you're here today and you like to be involved in a standard development process, there is a place and a role for you to be involved. Without going into details, but on the slides there is a link of where you can see all the corporations with European organizations that we cooperate with. Actors developing the standards at European level are coming from their national standardization body through the national delegation principles. So they are coming from industry, different types of industries, including SMEs, professionals, academias, laboratories, etc. And so they come from national level and to form what we call a European Technical Committee at European level. And within this technical committee at European level, they can create working groups. And so it is within this working group that the drafting of the standards actually takes place. And as said, cooperations with European organizations are needed within the standardization activities. So partners, liaisons are welcome to take part in these discussions and activities at European level. They can take part as observers. Here is to give you an overview of the bodies, the technical committees that are drafting standards for the personal protective equipment. So of course, CENTEC 159 on hearing protectors is one of them. This is of course a non-exhaustive list. So these technical committees are meeting twice a year within a sector forum. We call this the Senensenlek PPE Sector Forum. They meet twice a year to discuss horizontal matters such as circularity and sustainability for PPE. Another topic that has been discussed, not on the slide, is the dual use of products that are considered as PPE and medical device. And the sector forum also gives day-to-day guidance on the impact of the PPE regulations on standards. So if you're here today and you would like to join our activities, there is a room for that. We'll be pleased to hear from you. The first option is that you can send us an email via partners@Senensenlek to be a liaison to CENTEC 159, and also not on the slides, but there is a possibility to be involved in standardization by going to your national member of your country, and so the national standardization organization of your country, and request to be involved in standards, first of all, and then as said, secondly, you can send us directly to a request to be a part of CENTESY 159. And there is also a possibility to be a part of the discussions taking place within the CEN PPE sector forum. You can make a request through the link. I mean, this presentation will be made available soon, and you have the link to contact us, and we will get back to you. So I believe that was just a quick introduction to CEN and CENELEC. So I'm going to give now the floor to our next speaker, Giovanna, to introduce the work of CENTESY 159.
Good morning, everybody. And I think I should have control. Yes. So good morning, everybody, and welcome. Thanks to Jennifer. She explained perfectly how CEN works and the work of the technical committee. Today, I would like to go a bit more in detail on the TC 159 on hearing protection. My name is Jovan Alongo. I work for the company 3M. We are in 3M very much involved in standardization in a lot of standard for personal protective equipment, like respiratory protection, like head protection, fall protection, and I will forget some of them. But I happen to be, since 1 year, the chair of TC 159, which is a great honor and a great pleasure. So, and this is the reason why today I want to introduce you to the work of CENTESY 159. We feel like it's not very well known what we are doing. It's not very well spread. Some people, think that earplugs are not a complex product. They are tested. They are there for a reason, and that's what we want you to learn today. So, but first we start with a question for you. We want to know where you are coming from. I mean, what is your interest? Why you are joining in this meeting? So I would like to ask Els to start the first pool. So we make it a bit more interactive, and let's see what is going on. So
the first poll is in fact open, so I see people are starting to reply.
Perfect.
Well,
very good. So I see with time a lot of manufacturer. Great, there are some audiologists. This is very good because we need experts. So I think you are really the right place. And safety engineer is also very good, and health and safety expert. That's very good. And authority official, it's also very important. We do not see any medical doctor. I'm a bit sad about it, because you will see from the presentation from Sandra Dancher that we would love to have somebody, occupational health nurse or medical doctor. But that's the way it is. Maybe it's not today there, but they're registered and they will listen to the presentation later on. So I think we can end this pool. Thanks for participating. There will be other pool during my presentation and later at the end. So just be ready to answer. I think it's very easy. So I can close that, I suppose. And now we go for, yes. So why do we need hearing protection? I want to give you first an overview of the regulation around. So of course I have to start with the noise directive. The noise directive has been revised in 2003, and the noise directive is setting the minimum requirement for noise exposure at work. So it's really taking care of the health and safety of the worker, and setting the limit value below which it's still safe to work and is still not dangerous, but above which it's necessary to take some measure. A second part, right. A second important European directive is the Framework Directive, the 391, that is speaking about the measure to improve occupational health and safety. So if you, the most important part of this is that the employers to have to run a risk assessment for the worker. And if you think about it, what it means in a noisy environment, of course, to check the noise, but then also to see how I can eliminate the noise at the source. Can I buy a more silent machine? And we have to say, we see a very good and trend into less noisy machine where you know, there is less exposure to noise. But what we see also is that you need to make some arrangement in the shift of the worker so that they are not exposed all 8 hours of their shift. But then if everything has been done and everything has been from the organizational point of view has been taken care of, what is left are the hearing protectors. So it's the last resource to protect the people and the worker from noise. There is, for this, hearing protectors are personal protective equipment, and they, the 656, also the regulation is setting the employer's responsibility. Employer responsibility, it is, of course, to give personal protective equipment to the people working in their company, to train them, but also very important is to give an adequate PPE for the risk and for their personal need. So this means also that having the noise situation, they have to give the right PPE, and Peter is going to speak about, well, he is responsible of the working group on how to select hearing protection. That's very important, which are the basis. But also it's important to give hearing protection that fit the person. And while it's very obvious when you buy a jacket, a trousers, a pair of shoes, of course you choose the color and you choose the price, but they have to fit. You know, you are not going to wear some trousers that are not fitting. It's not possible. And that's the same also for hearing protection. The ear canal is different from person to person. The ergonomic and the size of the head is different. And this is also important. So that's going to be part of the discussion and the presentation of Peter. So I'm not going to go more in detail on that. And then finally is the PPE regulation, has been revised in 2016. And is setting the minimum health and safety requirement in general of all personal protective equipment. Here I just refer to the hearing protection device, and here it's an incredible piece of legislation which is putting together the work of manufacturers who have to produce products that are fit for purpose, that are not dangerous, that are really protecting, but at the same time, you know, it's calling up the notified body to test product, is calling up the certification process, the use of the CE mark, market surveillance authority responsibility. So it's all together. Very important. So if I look at it, you start from the noise directive, you go to the framework directive. Of course, we have also other ways to decrease the noise and the danger, that's clear. And then you have the PPE regulation and the use of the PPE. So now somebody will ask, hey, Jasmine, this is all at work. Yes, it is. That's what I said before. But the PPE regulation, the personal protective equipment regulation, is valid. And for any kind of use and any kind of PPE, doesn't discriminate between the use in professional area or in private area. That's also the reason why Sandra Dancher will speak later on a standard we are about to develop on children who are definitely not working, but it's important we recognize that it's necessary to have hearing protection for children. And you think about it, I mean, you are exposed to noise when you go to a concert, you're exposed to noise when you go to the Formula One competition, when you go to the disco. So all this is also important. And, you know, if you cannot avoid the noise, then you need to protect yourself. And that is where our group is working on. So I spoke about the framework of the regulation, which is very important, but I think it's not clear to everybody how difficult it is when you have some ear impairment. So we say that if you cannot see, you are taken away from things, from objects, and if you cannot hear, you are isolated from people. And this is really the case. You cannot enjoy a nice dinner with friends or family. And I've been in contact with somebody who had ear impairment, and she said that there are two saddest words that she had. She always hear is never mind. People are trying to speak to you once, twice, you say, sorry, I can't hear. You give the impression that you are not understanding, but no, it's a physical problem, you can't hear. And if they start to say, never mind, then it's where you start to feel isolated. And that is what we really want to avoid. And we are part of it, and a lot of education has to be done. And we still see, even in Europe, that we are not there where we should be. And the other problem is that you get subject to noise today, and you will feel consequence in 10, 20, 30 years. And that is the delay in time is giving really, is leaving out the sense of urgency that people have. Right, so now another pool for you. Do you know how standards are developed? So I think Else is going to put it now. Right.
Yes, it's on screen.
Perfect. So we want to know, you know, are you perfectly aware, or you're not aware, or you don't know in detail because you never participated? This is interesting for us to see. You know, I'm in standardization since 20 years. For me, is obvious, but I remember 20 years ago, I didn't even know what standardization was, which is, of course, normal. And standards, as Jennifer said before, are really important for creating a playing field around the world, same standard around Europe, but the ISO also around the world. So it's very interesting. So I see that almost 50% of you are very knowledgeable about how standards are developed. Some know about it, but never participated. And I'm very happy to see that people are never heard about, or they don't know how standards are developed, but it's very good. It means that it's a new public. Perfect. I'm actually very happy that to have this group of people here. So I think we have the information we want. Thank you. And we go to the next. Right, I want to discuss with you and show you the structure of TC 159. So TC is technical committee, as Jennifer mentioned before, and we have, I'm the chair since 1 year, and then we have working group 2, electronic and amplitude sensitive hearing protectors, working group 5 from Peter, guidance document, and then Sandra is leading working group 6 on general requirement test methods. So yes, so general requirement test method is for all kind of hearing protection. Communication is important because you can communicate even if you have hearing protection. And how do you do, and how you compensate the noise, the two different noise coming. That is what the group led by Magnus is doing. And again, as I said before, fit testing is a very important part of the work done by working group 5. And there you are again to another pool. And the pool is about, are you familiar with hearing protection device? Thanks for joining. It's important. We want to hear from you. Wow. Almost all of you are familiar, which is very good. I would love if somebody would say no, because then I would say, hey, we have somebody new in our team that knows. But perfect. Most of you know about it. 82%, 81%. I see now. Yes, I got my no. Perfect. So I hope you will learn something today during the seminar. Very good. And perfect. And then 18% no, but not in detail. So that's perfect. And that's why we are here. And right, so I spoke about the team, but here is the team. This is the TC 159, a lot of experts from around Europe, a lot of different character and different point of view. But at the end, as you can see, this is the celebration we did in year 2020. It was in the middle of the pandemic, as you can imagine. And in that year, we were very proud because we published 13 standards during that year. The work was not done in 1 week, that was done in several years. You can see on the right side, Dr. Martin Licke, who was the convener at that time. And yeah, that was the way we celebrated all together, being happy to have reached this success. So I think a technical community is a group of experts, is a group of very nice people. We do not all agree all the time, but you know, that is the beauty of it. You learn something every day. And now, how do we work? So since several years, we have been working in meeting twice a year, 4 or 5 days during 1 week. Then we have the week, 1 week in spring and 1 week in autumn. After the pandemic, we got a bit more comfortable at home, and we decided that the spring meeting is a virtual meeting. So we don't need to travel, but in autumn, it's a meeting in presence. That's why we find it very important, because it is a coffee break, it is in the evening in front of a beer, a steak, or a lemonade, where you can really, you know, understand each other. And we found that we do not agree with each other, but we respect each other. And that is really the big achievement of knowing where other people are coming from. So it's a great group. And I remember a very difficult meeting in Sevilla and in Dresden, but we managed. We had a beautiful meeting in Prague, in Madrid, Helsinki, and you name it. And hopefully we will go to Wrocław next year. Let's see. It's not 100% decided. Right, so I think that's my part, and now you get to the real stuff with Magnus. Magnus, please go ahead.
Yes, thank you very much, Giovanna. And I hope that you can hear and see me also now. So my name is Magnus Johansson, and I'm the convener of the working group 2, titled Electronic and Amplitude Sensitive Hearing Protectors. And our group is responsible for hearing protectors where the effective attenuation can vary due to electronics or the electrical function or mechanical function of the product. So in Europe, we have a long tradition of hearing protection devices, but also products that offer communication solutions. So there has been development of communication solutions since the World War II or since mid last century. The early solutions offered both the possibility to connect to communication systems, but also to protect the hearing. And that could be, for example, to connect to a military aircraft or to a vehicle. And this has, over the years, evolved into various solutions to connect to communication systems, smartphones, broadcasted radio, or even built-in communication radio systems into the products. And there are many examples of work situations today where you have the need for communication and communication solutions, where the communication is critical really to the work and to the safety. But in the same time, you are in a noise environment, so you need a sufficient protection performance as well. So the technologies today aim to combine these two needs and to offer both the protection part as well as the communication or even entertainment audio, for example. So with the product development and the technology development, there is also a need to develop standards in this field and to make sure that we have product requirement standards and test method standards that are in line with the products on the market. So the scope of the working group 2 is to develop the product requirements as well as the test methods for this category of PPE. And already in 2002, we had a series of product requirement standards for this type of hearing protection devices with electronics, with electrical input, or with a level-dependent function, or with an active noise reduction function. And a few years later, there was also a standard on products where you had a built-in entertainment audio receiver. And with these standards, which were harmonized to the European Personal Protective Equipment Directive at that time, there were well-defined requirements and methods for these products that was put on the European market. And this means that the hearing protection devices that offers these type of features, they have to comply to both the requirements on the protection, hearing protection part, which is in the standards EN 352 part 1, 2, or 3, as well as the requirements in this series of standards EN 352 part 4 and higher. So over the years, the standard has been improved, and in 2020, we published an update of the whole series of EN 352 with both revisions of each standard's content, as well as a restructuring of the series where we separated the requirements from the test methods. So today we have this list of requirement standards, EN 352 part 1 up to part 10. And we have put the test methods in a separate series of standards called 13819 part 1, 2, and now also part 3 for methods related to electronic hearing protection devices. And I will concentrate more on the 4 standards today related to the safety related audio input and entertainment audio. And this is covered in the part 6 and part 8 for earmuffs, and in part 9 and part 10 for earplugs. And the methods are described in this 13819 part 3. So for both earmuffs and for earplugs equipped with a communication facility, there is the same list of requirements. And the main requirements are to declare what's called the critical input signal, which means that the input signal to the product that results in an output level of 82 dBA effective to the ear, that input signal shall be declared. And the second requirement is to declare the relationship between this output level and the input signal. And this is declared in 5 dB steps from an output level of 70 dBA up to the maximum possible input signal. And then the sound output level, the maximum sound output level, the output level for the maximum input signal shall also be declared. So basically, the highest signal you feed to the product will result in a certain level effective to the ear, and that level shall also be declared for these type of products. And finally, we should also declare the usage time for the maximum input signal that corresponds to an equivalent sound output level of 82 dB over 8 hours. So this means that we have requirements to declare this relationship between what is sent to the headset or the in-ear communication device and what is reproduced on the inside, effective to the ear. Even though we don't have any maximum level or no limitation in a specific number. And the reason for that is that sometimes the critical communication it sometimes need to be overriding the noise level, and it's usually limited in time, the exposure to the communication signal. And the test methods for to determine this type of performance criteria is described in the method standard 13819 part 3. So if the hearing protection device is equipped with a function of entertainment audio, there are different requirements. And for these type of products, now there is an requirement on the output level or the equivalent level effective to the ear, where the product shall not exceed 82 dBA in average. And this includes products with an FM radio receiver built in for broadcasting radio. And it includes electrical audio input, which in this case means that you connect with a cable to an external entertainment audio equipment. So the separation is between what type of signal, if it's entertainment audio or if it's critical communication. And the third part here is Bluetooth audio input, which today usually means that you're streaming music from your smartphone, for example. So this means that if you are listening to music or a podcast or something else that is not considered as communication, critical communication, if you're listening to this type of entertainment audio, the hearing protection device will not put you at risk due to that communication, that entertainment audio. This is a precaution of how the entertainment audio is presented. And previously, the method to determine this was incorporated into the requirement standard, but with this restructuring, we have now separated this. So requirements are described in these EN 352 parts, and the method to determine this is described in the method standard 13819 part 3. So most recently, our working group 2 has continued to add requirements for products with additional technologies. And we are just about to publish an amendment to this part 6 and part 9 regarding products with a built-in analog frequency modulated two-way radio. So that means similar to traditional two-way radio, handheld radios that are built into hearing protection devices. And this includes products that are not connected to external communication, but have the communication built in. And another upcoming amendment concerns entertainment audio functions in part 8 and part 10. And with the digital audio broadcasting, DAB radio, as an option to traditional FM radio broadcasting, there are now also products with built-in DAB radio receivers. So this amendment includes requirements for that type of technology as well. And the methods are also added to the method standard for this. So with new technologies on the market, there is a continuous need to add and revise the requirements, and in particular the test methods, how to test these products. And So experts in this technology field are most welcome to contribute to this process. So currently, our working group is addressing another type of products that are not yet covered by the EN 352 standards. Earplugs with built-in active noise reduction, ANR earplugs, are available on the market today, but there is not yet a defined test method for examining these type of products. So the requirements on the products will be similar to the earmuff style of the products, but the technical challenge for the working group is to define the test method to be used when determining the performance. And we are developing a method that can be used without test subjects, but still representing a realistic performance with real subjects. And another work item within working group 2 is the development of a test standard for hearing protection performance in impulse noise. So today there is an ANSI standard in US published that describes a test method. That standard is currently under revision. And there is also, in the same time, a development or a project in ISO to establish an international standard on this topic. And our working group within CEN are looking into how to establish a corresponding European standard. And at the same time align the work with both ISO and the revision of the ANSI standard. So to conclude, the technology and the product features continuously evolve together with the technology development, and the standards development sometimes follows to make sure that the product put on the market are safe, and sometimes the standard development is progressive and ahead of the product development. So TC159 is a very interesting and well-functioning technical committee. So with very interesting technical and regulatory challenges. So if you are interested in this topic and would like to contribute to this work, you are most welcome to join this important work to make the occupational environment safer. So by that, I hand over to Peter Sickert and the working group 5.
Thank you, Magnus. I have to try.
In the meanwhile, while you were speaking, Magnus, some questions came in particular for you. So if you can just have a look. And of course, I invite Peter to start his presentation together with you looking at the questions. So yes, Peter, the floor is yours.
Yes, the floor is, it's good. And yeah, it's possible to change the slides. Yes, my name is Peter Sickert. I'm convener of the working group 5, you heard it. And I'm also the head of the German Mirror Committee for Hearing Protection and work as a consultant in a small consulting company. So what are we doing? What are we doing in the working group 5? Yes, the original deals the working group with the appropriate selection, use, and maintenance of hearing protectors. The name is also selection and use. This is a special case. The special case standard we had for a long time is a user standard. It contains no requirements to hearing protectors, and no test methods. It's really a standard. You can use it like it is, or you can transform it in your country in a national information or regulation. But in the last few years, some topics have been added besides the selection of the hearing protectors. I will describe it later on. And it is necessary to handle with fit testing systems, and so the selection and use of fit testing has been prepared. A standard has been prepared by our working group in the last few years, and at the moment we are discussing the requirements on fit testing systems. Let's start with the original standard. What we have at the moment, it's from July 2016, but currently is being revised, the standard, in our working group, in the project group of the working group, as preparing it for the working group. The reasons are first, the PB regulation. The new PB regulations have transformed the hearing protectors from category 2 to category 3 in the highest group of personal protective equipments. We have to include the new fit testing systems, not included in the old standard, and we have to consider the revision of the series of 352 series, and what we have heard at the moment. We have prepared new in 2020, that the results we have to include in the EN 458, and that's the reason why we have to transform it. I will give you some information about the content. An important part is, and I have it here as an example, is the aspects of the selection according to the sound attenuation. We have in the standard 4 methods for it: the octave band method, the HML method, the HML check, and SNR method. The methods have different accuracies. Different accuracies, and the octave band method is a method with the lowest measuring uncertainty. You have to measure all octave band frequencies, and from this octave band frequencies you calculate the sound attenuation of the hearing protector. And after that, you can select what the hearing protector, what is the right hearing protector. The mostly used method is not the octave band method, it is the HML check. It's a quick method. In this method, you have to subtract the laboratory determined sound attenuation from the measured sound level at the ear place, and you use the M or the L value. This is a calculated value for middle frequent or low frequent noise. And for this is calculated or determined within the type examination procedure. And this value you have to subtract from the measured sound pressure level at the ear, and you have the residual level at the ear after this. And and from this you can explain, is the hearing protector good, or is it appropriate for the work situation or not? If the measured residual level at the ear is higher than the national regulation level L-NR, the protection is insufficient, and you have tried to select another hearing protector with a higher attenuation. Is the sound level lower than the residual level is lower than the national regulation level, then the hearing protector is sufficient, but the sound attenuation shouldn't be never too high nor too low. If it's lower than 15 dB beneath the national regulation level, then overprotection is possible. And it is not in each case overprotection, but overprotection is possible. And so you have to check the audibility of speech or warning signals and ask the user if they have a bad feeling of isolation or so. That's an important part of the EN 458. What we have a special problem when we use this method. It has been shown in the recent years that the value at the sound pressure level at the ear is higher than calculated. The reason is the sound attenuation in practice is mostly lower. We call it real-world attenuation. The possible reasons are the ear anatomy, the special shape of the ear canal, or if wrong use, or poor maintenance of the hearing protector. You see two pictures on the drawing on the left side. You see hearing protector in a right position. That is a disposable earplug, but this is deep enough. And the ear canal on the right side on the picture is a not appropriate use of an earplug. You can see here the ear earplug is looking out of the ear, is not deep enough in the ear canal. And I would say you have a sound attenuation of maybe 3 or 5 dB, not more. This is, yeah. So, and as a result of this knowledge, different derating methods have been established in the European member states in the recent years. And I can't discuss it; it's very complicated. Each country has its own way. In Germany, we have derating values, and you see beneath there is an example for a disposable earplug and in middle frequency noise. What's the most cases you have? The most cases, and you have to subtract 9 dB and calculate the residual level at the ear with the M value minus 9 dB. If you would have an ear muff, it would be minus 5 dB, or you would have a custom molded earplug, it would be minus 3 dB. This is the way in Germany we go. Okay, but what we use there is a statistical method. That's our problem. And the result of the discussion, it could be that the sound attenuation is very much lower as as 9 dB, or it is better as a higher sound attenuation. And the result of this discussion was the development of a new standard. The result was the development of fit testing methods, and we had the task from the TC 159 to develop in the standard. This is EN 7479. We have published in November 2021. It is also a guidance document, a guidance on selection of individual fit testing methods, not requirements of fit testing, only guidance document. We don't say this fit testing method is good or bad. We describe where is it good, usable or not usable. We have 5 test methods in the standard, to describe all test methods that are known at the moment. This could be objective or subjective methods. The method 1 is an objective method. You have to measure the sound level with 2 microphones in the real ear, Meyer technique genannt, and called. You see 2 examples here. It is, you are measuring both values, and you see from them the method of Theatronic. It's the ear guard. On the other side is a system, we call it, is a 3M system, ear fit validation system called. You can see on the picture on the right side, there's 2 micros. One is outside the ear plug and one is inside the ear plug. And this is a method with the lowest measurement uncertainty. The next method we have is also called Audiometric method, based on audiometric systems. There you have to determine the threshold of hearing with 2 times, with and without hearing protector. And you see on the right side is a computer-based system. And on the left side, you see the result. You have on the right and the left side the hearing threshold curves of the ear, one with hearing protector and without hearing protector. Red is his right ear and left is blue is the left ear. And you can see from the difference of both curves, is the hearing protector is a good fit, or has it a leakage? If the frequency curves down from 500 dB, 500 Hertz to 125 Hertz are nearby, then you have no sound attenuation in this region, and you can conclude that is a leakage in the between ear and the shape of the ear canal. And so you can, the medical doctor can use it like this is a system used from the medical doctors in the companies. The next method we described in the standard are audiometric-based methods. They are not very different from this. They are developed by manufacturers. The difference is that they are specialized for the systems, for the earplugs the manufacturer have developed, and they are not really different, but they are tailored to their own product, you can say. Measuring also the threshold of hearing. Method 4 is a loudness balancing system. You see it on the right side left, on the right side down, and you are measuring the sound, the loudness on the right and the left ear without and with hearing protectors, and from comparing it, the system calculates the sound attenuation. What's not possible are method 5, and what's not visible is method 5 and 6. An acoustic leakage test, there is measuring the reduction of the sound pressure level when the earplug in the ear canal, when the leakage is, you can measuring lowering of the sound pressure level, and what we call ear leakage test. There you is used measuring the decreasing but also increasing of the sound pressure beneath the earplug. The most important thing for my feeling in the standard is a table with the application fields of the different fit testing methods. You see here in the heading, there are the test methods beginning with sound level Meyer technique and ending with air leakage test. And in the first column, you see the most common using situations or application fields. And you see mostly small crosses, but there are some small lines. And when we are looking on the health surveillance, you see it on the picture on the left. There are all systems are possible to use without a loudness balancing system. This is the reason is the system you have a problem to calculate or describe your loudness exactly, and so we have a disadvantage of a system. When you look down to verify the adequacy of the attenuation to noise level at the workplace, then all the loudness balancing, the acoustic and the ear leakage tests are not usable. So other systems you can use, but for audiometric method and audiometric best methods, it is necessary to measure all frequencies to calculate it. And so that's an example. What very good, the loudness balancing system is usable in high environmental noise, and so it's good usable for training situation or awareness increasing. It's a different situation. So each system has its advantages and disadvantages. Yeah. So let me say for the system, what we call the method 1, there it is necessary if you have formable earplugs, then it is necessary to use surrogates. If you have custom molded earplugs, then it's not a problem, or flanged earplugs. Yes, so each system have advantage and fields of application. In 2019, we had the upcoming result that this what we are doing is not clear. We don't know exactly what is the requirements is, how exactly it works. And from this discussion, we opened the scope of the working group 5 in 2019. The first part is the old version. We give guidance on selection and use, maintenance of hearing protectors. but we additional said the working group is responsible for the development of performance requirements and test methods for the fit testing systems. Yes, the new work we are doing at the moment is develop performance requirement for the system. That's not really easy to do. We are, yes. We have, in the meantime, we have a draft of the new standard with performance criteria for fit testing systems. What we want to do is to partly use the American standard, the ANSI S12.71. The colleagues have done it in the past. 2018 is what was published. They describe performance criteria for fit testing that estimates the attenuation of passive hearing protectors. It's nearly that what we want to do, but we go a step ahead. We want to go a step ahead, not only performance criteria, but only say that what is the requirement of the system, and it will be a step further on. But it's not too easy to describe. The mathematical description of the measurement uncertainties, the different uncertainties, and the accuracy of the systems. And that is well done, very good done in the American standard from our colleagues. And we want to take over. What we also take over, but we write it, what's highlighted here, you see these are the parts we want to take from the ANSI standard. What we also describe, or want to describe, a qualitative approach you need it for the air leakage test, maybe with only a pass-fail criteria, and a quantitative approach, a quantitative system that would be then much more exactly in the result. You can determine then a PIR value as a personal attenuation value. The PIR's personal attenuation rate, and maybe you can compare it with HML values. This is our task we do at the moment, but that is in the beginning. It needs some time, of course, and I would like to summarize. We have also to appropriate selection of hearing protectors and the correct use of hair protection. This is our original task of the Working Group 5. Then additionally, we have the individual fit of the hearing protectors and the derating of the sound attenuation in the practice, what is discussed, or we will discuss in the group. And we have now also guidance document on the selection of the individual fit tested methods. And in the future, we want to have a performance criteria and a performance criteria for the several fit testing systems. But we have a problem. You see it on the right. The future of the Working Group 5 is not really clear at the moment. From 2023, we have no convener and no secretary available. There are financial reasons, and we would be happy if you could support us. Every kind of support will be or is welcome. So I think that's all. Thank you very much on my side. I would give over the floor to Sandra. So, and now I give over.
Yeah, thank you very much for handing over, Peter. Welcome also from my side to the last presentation of this webinar today. My name is Sandra Danscher. I'm the convener of Working Group 6, Hearing Protectors General Requirements and Test Methods. I'm working for IFA in Germany. It's an Institute of Occupational Safety and Health of the German Social Accident Insurance. And we're a research institute and a notified body for PPE and machinery. Today, for today, I have chosen a topic which should give you insight of how many aspects are to be taken into account to test and certify hearing protectors. And it's a current project where it's work in progress, hearing protectors and especially earmuffs for children. I start with the scope of the working group, and I would just like to point out two aspects. And for some parts of my presentation, I'm lucky I can refer to things that my co-workers already have presented to you. Here, back to the scope. This working group takes care of the basic standards on hearing protectors. That means regarding the passive functionality. And that also means that they are applicable to all products, also those with supplementary electronic functions, as Magnus has presented them. And the other aspect is that product standards defining requirements are harmonized standards to give presumption of conformity with regard to the PPE regulation. And here we have a closer look on the standards in the responsibility of the working group. We have the series EN 352, you have already seen the requirement standards, and this working group here is responsible for parts 1 to 3. Part 1 covering ear muffs, part 2 ear plugs, including custom molded ear plugs, and part 3 mounted ear muffs, like for example this helmet mounted ear muff. Testing procedures are separate in the series EN 13819. Part 1 deals with physical test methods like adjustability and headband force, and part 2 with acoustic test methods, for example, the sound attenuation. Regarding hearing protectors for children, I would start with a more broader view on PPE for children in general. There are products available that are well known for many years, for example, helmets for biking or skiing, or also life jackets and climbing harnesses. Another product group, respirator masks, has gained a lot of attention due to the pandemic. I think everybody's aware of these nowadays. And we also know for some years, hearing protectors for children, ear muffs, and also ear plugs. Yeah, the fields of application for hearing protectors for children are usually not workplaces, as Giovanna already mentioned, but leisure and sports situations where there can be high noise levels, for example, music events or car racing. But sometimes we also see hearing protectors in schools if pupils have to work on their own and need a means to enhance concentration. You have already heard that the PPE regulation is also valid for private use of these products. And if you know the standards, the existing standards of our TC, you may see that this has not been in the focus so far, but it's we see the need to change that and to cover also products for children. As I said, there are products on the market. Here just some words how these have been certified. For some products, it is possible to apply the existing standards. An example is shown here. If an ear muff is large enough to fulfill at least the size range S of EN 352 Part 1, of course, it can be tested and certified according to that standard. For ear plugs, it's also in most cases no problem. Additionally, there are recommendations for use sheets. These are agreements between notified bodies on technical questions, and these documents are also approved by member state representatives. With regard to these products here, we have sheets that specify additional instructions and warnings for parents as part of the user information. And there are also other products, for example, smaller ear muffs for babies or toddlers that have been also tested and certified based on test procedures that have been specifically developed or adapted from existing procedures. That is also possible, but there is so far no standard covering the whole product on all aspects. Before I come to our current project and the ideas and progress we have made so far, I would like to give you some insight in the existing standards and the methods for hearing protectors for adults. And from that, we'll see what is still open, what needs to be changed. I picked out 2 examples. First, the adjustability of earmuffs, giving the size ranges that are declared with the products. And second, the measurement of sound attenuation. This is a special case because we need here test subjects. And it is straightforward that test procedures and requirements for children's hearing protectors are affected by the reduced size of the products, but also by special characteristics or special needs of children as the group of users. Good, let's start with the sizing of earmuffs. Our testing standard specifies values for test width and test height for these earmuffs for 3 different size ranges. And we use test fixtures or also such test head forms for checking this. Here I show you the table from the testing standards. There are 3 values for the test height from the ear to the top of the head and 3 values for the test width. That means distance between the ears. And we'll see later on that is, for example, the smallest value of 125 millimeters for the test width is much too large for the head of smaller children. These values in the existing tables cover the adult population, males and females, but nothing else so far. Second example I would like to present is the sound attenuation. The measurement, we use the method of EN ISO 4869 part 1, the so-called real ear attenuation at threshold. And you can see on the right 2 pictures from our labs. We produce a sound field with these 4 loudspeakers. The test subject sits on the chair in the middle. And on the next slide, I will show you a short video of such a measurement, and you can see how it looks like in practice. The idea is to measure the hearing threshold in this sound field twice, with and without the hearing protector, and the difference is the sound attenuation. And we do that for a number of frequency bands. We indeed need test subjects to get a realistic fitting and from that realistic attenuation, and we need also 16 subjects per product to get a range of values that is representative. And with that, it comes also that we take care to get also anthropometric range of the target group that is representative of the group of users. One additional condition regarding the subjects, they have to be able to reproduce their threshold of hearing quite well, because we have to rely that the difference of 2 consecutive measurements with and without hearing protectors is correct, and is indeed the sound attenuation. Okay, then let's have a look on the procedure itself. On the right, you see the subject, and there on the handles on the armrests, there are buttons. And if you look at the right thumb of this subject, you can see when he presses the button or releases it. On the left side of the screen, there will be displayed the sound pressure level, increasing stepwise in the beginning. When the subject is sure to hear it, he presses the button, the sound pressure level is decreased, then the button is released if the level is too low, and we make some of these ups and downs. It's a bracketing method to get to the exact value of the hearing threshold, and from the turning points, we then calculate this value. Yeah, we do that for 8 frequencies, and you can imagine it's quite a challenging task. You need concentration and a good hearing ability. Okay, with that background, let's come to the project we are working on at the moment, testing and certification of earmuffs for children under the age of 5 years. At the beginning, we have directly identified some very prominent open questions. First of all, sizing. I have shown you that the headforms, what headforms we use, and it is clear that we need smaller headforms for checking adjustability to make sure that the products can be fitted to the heads of children. From that, it comes that also some test equipment needs to be needs to get in smaller versions too. For example, for measuring the headband force, or the acoustic test fixture for measuring insertion loss. And then, of course, we come to sound attenuation. I've shown you how that works. We need to discuss if it would be possible to do that with children, if down to which age we could get reliable results. Or for some products, it may be possible to measure with adults with suitably small heads. And one additional idea would be to use, in this special case, artificial heads, what we normally can't do. We have to rely on test subjects, but that is still in discussion, but it's a very crucial point, as you can imagine. What have we achieved so far? Firstly, we agreed to limit this age range to 2 to 5 years. That means in the first step, exclude the very small products for small children. Then we have investigated about anthropometric measures. We are in good contact with the working group of TC122 that is dealing with children's anthropometry. They also organized a webinar like this one last November, and they have published a technical report. Also, both very helpful sources. And from the data we have available, I've just show you one example. It's a bitracheal breath, our test width again. And our smallest value, 125 millimeters, is way too large. If we look at the 5th percentile of girls' heads, that means the smallest ones, but that makes it obvious that we need smaller test headforms. Another topic we have been discussing are ergonomic criteria. For example, the headband force. For the products for adults, we have a maximum value of 40 Newton. But what would be a suitable value for children? And there the idea at the moment is to investigate the headband forces of consumer products like headphones to see what values are available for the products on the market, and that means what values would be tolerable for children. And we also want to include notified bodies in test labs directly from the beginning. With and without previous experience in testing these products, that doesn't matter, but to make sure that the new methods we develop are really usable in practice. So that's the current status of this project. With that, I come to the summary. It's the overall goal of the whole TC, and of course also of this working group, to protect the whole population exposed to noise. And we know that a relevant part of the exposure can lie in the leisure side for all age groups, and of course for children, it's mainly on the leisure side. For our new standard, we have to take into account, on the one hand, the needs of the children as the primary target group, the users, but also the needs of the parents, since they choose the product and apply them to their children. That means they need suitable information and instruction how to do that correctly. And I showed you several examples that we have to change or adapt established procedures, and the most prominent thing is the determination of sound attenuation. So bringing that all together, I think you have seen that this is a complex topic with many different aspects, and that also means that we need a lot of different expertise. And with that, I come to my last point. We would be really happy to get additional input, also perhaps just for an experience exchange. They have listed some of the fields, audiology, medicine, anthropometry, but also additional test labs and notified bodies. And bringing all this together, I think we will be able to get to create a new standard that is fit for the products and fit for the users. Yeah, that's all from my side. Thank you very much.
Thank you, Sandra.
Oh,
Okay.
sorry.
I was just going to say that a few questions for Sandra came in while she was talking.
Okay, I will take care. Thank you.
Right, I saw that Magnus has already answered the question. Peter is doing that. Of course, some questions are very technical, and therefore it's taking a bit more time. I think we have the last pool, or probably the last plus one pool before we conclude. So we are curious to know if you have some knowledge where you can contribute. Now you have been listening to what the working group is doing, what we are working on, and so just feel free. Do you have any knowledge? And it's I think we are very happy if you have the possibility to learn how complex is the work, but how dedicated we are and how it is important is this work for us. So I'm very happy to see there are some yes and some maybe. And unfortunately, no is also perfectly okay. Hopefully you have been learning something and you are kind of helping the better understanding of the big problem of hearing loss and hearing protection in whatever function you have in the society. So I think with this, I think Sandra will finish to answer some question, and I can probably conclude here the presentation and the webinar. Maybe Sandra, Magnus, and Peter and Jennifer, you want to come also again on the screen. It's a great work we are doing together with Jennifer, helping us also with the contact with the European Commission and explaining us also what to do with difficult standardization question. What you don't see is our secretary from DIN, Nora Friedrichs. She is a very valuable support in all the work we are doing, but she's in the background taking care of that the slides are properly shown, so I don't want to disturb her. So thanks, Nora, for all the work you are doing all the time for us. I see that there are some 30%, 33% maybe contribution possibility. Yes, is 18%. That's also great, and 50% is not. So thanks for this last pool. So here we are. If you have other questions, you can type them in the chat. Otherwise, as Els said at the beginning, the presentation, the registration, and the Q&A will be available for everybody. You will have also our email address. There are different ways you can contribute. You can contribute from your own country, in your local standardization institute, but also you can contribute coming to the TC under 59 meetings and working groups. You may decide to have more interest in one working group than the other. And so any kind of contribution, it's more than welcome. I hope you enjoyed this very technical webinar, and we have been able to raise some of some interest. So else, anything else to add here, concluding?
No, Giovanna, I think you all said what should have been said. So I would like to thank also all the speakers of today. And as promised, we'll share with you all the material we have. So I hope for all of you that something interesting comes out of this webinar for the future, of course. So all the best, and see you maybe next time. Bye-bye.
Thank you. Bye-bye, everybody.